name is Miss Meg.
And I'm Miss Abby.
Welcome to Weather Makers. We are from the Asheville Museum of Science, which is located right downtown in Asheville. If you guys have never been here before, you definitely should try it out. We are open now with limited capacity, but we have some really cool things going on. Miss Abby and I are both STEM educators, which is science, technology, engineering, and mathematics. So we do a lot of different things, which is awesome. We love our jobs. We love changing it up and teaching as much as we possibly can to students and the community. And we're really excited to have you guys here today listening to us talk about weather.
Yeah, so shortly we're going to have a couple activities. We're going to make some weather instruments together, but we can't start that without knowing all about weather. So what are we going to talk about today, Miss Meg?
We are going to be talking about all the things that encompass weather. So weather has a bunch of different patterns. They have all these different factors that create change, right? So I'm sure you guys have heard these terms before, like temperature and air pressure. And obviously, it rains sometimes and it's sunny sometimes, but why? Why does that happen? And we're gonna hopefully figure that out.
All together though, right?
Of course.
So we're going to start first by talking about what even is weather. So we hear that a lot, right? Like, oh, the weather today is very sunny. So I'm going to pull up my screen real quick and just share with you a short little slide that kind of helps discuss what weather is. So right here, all right, so we have this slide up here, and this is really helpful because we can kind of visualize the difference between these two words, weather and climate. So weather is what we've been talking about. It happens day to day. We see it in the morning on the news, our weather forecast. We hear if it's going to rain, and we know if we should wear a rain jacket or bring an umbrella, which in Appalachia is most likely yes. Just don't leave the house without a rain jacket. But weather is actually very different from climate. So weather is that day-to-day change in the what's going on outside, but climate is describing those long-term patterns, like Miss Meg was talking about. And so you can kind of see it on the map. This is a world map at the bottom, and you can see that it's shaded with a lot of different colors. That is because those areas have patterns to their weather. So their day-to-day weather has yearly and multi-year. So over long periods of time, they will show the same patterns. And that's how we can get good at understanding weather. So Miss Meg and I are going to play a short game, and we are going to try and learn the difference between weather and climate. And so I hope you play along. You can go ahead and pause every time that we come to our question. So we're going to have a few prompts that we are going to have to distinguish. Is it weather or is it climate? All right, Miss Megan, ready?
I think so.
Okay. San Francisco has moist, mild winters and dry summers.
I think that's climate.
That's climate, right? Because we're talking about the seasons. This happens every year in San Francisco. Great job. Next, the Arctic is dry in winter because with very cool temperatures, little water will evaporate into the atmosphere.
So that sounds like that happens all the time. So climate?
That again is climate. Exactly right, Miss Meg.
Oh, yeah.
So since that happens every day, all day up in the Arctic, we consider that climate. It would be out of the ordinary if it changed. All right, on to the next. There was a frost overnight that damaged crops in Florida.
Oh no. Well, that happened one time on one day, so probably just weather.
That is exactly right. It's just weather. Hopefully we won't have those continued prolonged frosts, right? Because we need our oranges. Yes. Canadian geese, ooh, this one's hard. Canadian geese migrate south to a warmer climate in autumn to find food.
Oh, well, it mentioned climate, so has to be climate.
It is. So the Canadian geese are migrating every single year. We track that. So they follow the climate patterns. All right. Oh gosh, Florida is getting hit by a hurricane right now.
Oh no, Florida. Well, so that doesn't happen all the time, just like the frost. So that's a weather pattern.
Right. It's happening right now. They're checking the weather and they're saying, I'm not going to go outside. Hopefully.
Good choice.
The weatherman forecasts cooler nights for the next few days.
Cooler nights. Probably a change in temperature, which is weather.
Yeah, so this one is a little tricky too because it says for a few nights. But just a few nights, like a week, isn't really the same as saying for the entire month or the entire next 3 months. So very good. That's an example of weather. All right, Alaska averages 200 inches of snow every year.
Every year, well, if that's not just one day and that's not changing over all the years, then climate.
I think we're going climate on that one, and that is absolutely right. All right, just about 5 more, and then we'll move on. All right, we're really going to master our weather and climate today. All right, the heat wave in New York City lasted for 4 days.
So lasted for a few days, but it wasn't for a long period of time, and it wasn't over a couple years, so it has to be a weather pattern.
That is exactly right. That is a weather pattern. All right. I needed a sweater today because it seemed a bit chilly for October.
So it's chilly in October, so weather?
That is weather. So typically it can get chilly in October, but this statement makes it seem like it's kind of out of the ordinary to be this chilly in October. So that's implying that that's kind of a random weather event that day. So weather. All right, last 3. The forecast calls for rain on Sunday, but sun on Monday.
Sun and rain, different days, so I'm going with weather patterns.
And you are absolutely right, Miss Meg. All right, we are like 10 for 10 right now, so let's see if Miss Meg can finish strong. The Sahara Desert is one of the driest and hottest regions in the world, with an average summer temperature of 104 degrees.
Well, it's talking about a huge area and something that happens is happening all the time, so climate.
Exactly right. And we have the final question for Miss Meg. Can she do it? Yes, she can.
Yeah.
The rainforests in South America are hot and humid year-round.
I got this one. If it's year-round, it has to be climate.
Great. All right, so now that we've mastered the difference between weather and climate, we need to know where weather comes from.
So what causes weather? I'm really excited to teach you guys about it. I want to talk about it because it's really important to understand all of the different things that cause weather. Weather isn't just one thing that we can hold and understand with one definition. We have to understand the aspects that affect it, right? So the one thing that we can see on the screen, and hopefully everyone can feel every day, is when we walk outside, we can feel the temperature it is outside. If it's really cold, if it's really hot, it will affect the different patterns of weather, right? And not necessarily climate, because that's a different thing, but your everyday to day changes in your weather. The other thing that affects weather is your air molecule density. So that's kind of a difficult term, but it just means how close together the air molecules are. So if they're really, really closely packed together, it's going to be more dense than if they're spread apart any further.
Great. So Ms. Meg mentioned 2 of the most important factors, temperature and air molecule density, but we also need to talk about air pressure. So look up. You don't really see much, but there's actually a lot of air above us, right? And that's what our atmosphere is. So as weightless as it seems, it's actually pressing down on us. And that's why you might hear the word air pressure. So that's that atmosphere and that air above us that's actually pressing down on us. And that's always changing based on the factors that Miss Meg was mentioning. So our air pressure is going to change all the time because of our temperature and because of air molecule density.
Thanks, Ms. Abby.
A really good way to understand kind of what our atmosphere does is to look at fruit. That seems kind of odd, but it's actually a really good idea because we can think of our Earth as the actual fruit, and we can think about the atmosphere as the peel. So if I peel this banana open, this is not my banana. this peel is kind of representing our atmosphere. It's protecting the earth or the fruit underneath, right? And one thing to note about the atmosphere is something called atmospheric circulation. And so that blanket of gas that shields us and keeps us warm has a lot of different environments to it. And each layer of the atmosphere, as we get further and further and further into space, is going to change with those air molecule density and the temperature, which is really what's going to affect the weather. All right, Miss Meg, what do you say we go outside and check out what weather we have today?
I would love to.
Hey everyone, it's Miss Meg and Miss Abby. We finally got outside and we're gonna talk about the weather today. It's extremely sunny and it feels great. I think it's almost like 65 degrees.
Yeah, it's almost like 70, which is kind of weird for October, right? Example of weather or climate.
It's November!
It's November! So, it's November, right? Winter's coming, at least where we live in these temperate forests. And what does that mean? Well, it really means that the Earth's position to the sun is going to change. And probably for a longer period of time than, well, definitely for a longer period of time than just one day, right? So a long chunk of the season is about to come up, and it's going to be winter and a lot colder.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continent. During winter, continents in this view turn dark from a lack of photosynthesis.
So as Miss Abby was just talking about how we're about to experience winter, a lot of things are going to start changing. And by things, I mean weather, right? So let's think about those aspects that are going to change in winter. What can you think of?
Temperature!
Temperature, exactly. So our temperature is going to be changing. It's going to be getting a lot colder, which means that there is going to be less humidity in the air as well. Have you guys ever heard the word humidity before? It just means that there's different amounts of water molecules in the air, and when it gets cold, when winter comes, when the weather changes, there's going to be less humidity. We're also going to be experiencing different types of precipitation.
What does precipitation mean, Miss Meg?
Precipitation is when the clouds get full of moisture, full of water, and then those water molecules come down. They can come down as rain or snow or sleet. So in the winter, sometimes we get snow, which is definitely a different weather pattern than the summertime.
So now that we know what weather is, how do we measure it? And how do we predict it? Miss Meg and I are going to take you back to the classroom now so we can look at some of our weather instruments to measure all of these types of weather, from wind to precipitation to humidity and all the other things we've talked about today. Let's go.
Take off my jacket because it's really warm, right? All right, so now Ms. Meg and I are going to start talking about some of the weather instruments, like how we measure weather. And the reason that's really important is because that's what helps us predict weather. So we'll start out with some of the more simple ones, and then we're going to jump into some of the less common ways to measure weather. So Ms. Meg, would you like to start?
Absolutely. So what I'm going to start with is what we kept saying today, and it's really simple. The temperature, right? So what we use is a thermometer. We have a thermometer right here. There's a bunch of different kinds of thermometers, but the way that we measure temperature is in degrees, Fahrenheit, or Celsius. And that just depends on what way you're using it, but it's pretty simple to understand, and it's, again, really important to understand how hot and cold it is for all the other things that go on with weather.
Yeah, so in the thermometer, when the weather heats up, it's going to expand and push up. There's actually mercury in here, and it will push up the mercury up here. So we'll kind of see a symbol or like a line drawn of where the temperature stops. So if we see, you know, it's up here, it's going to be 200 degrees Fahrenheit, which probably not outside, but maybe in a sample or in a boiling water or something. So temperature, again, a really good way, thermometers are a good way to measure it, and very important part to our weather. All right.
The next thing that we have is, again, something pretty simple, and it has to do with precipitation. So when it rains, how on earth could we figure out how much rain is falling down? You can't just stick your hand in the grass and figure out how much rain it just poured down, because the rain either runs off or it gets soaked up into the ground. So to measure precipitation, we have a rain gauge. And that's really, really simple.
That's right, Ms. Meg. It is just basically any cup. So a rain gauge is a way to track the amount of rain that's falling over a certain period of time. This is going to tell us how much rain is going to fall during the hurricane that's coming for the next 3 days. And that's really important information. So we know that we need to move our car if our parking lot's going to flood, or if there's something called storm surge, and that's when a lot of precipitation falls down and floods rivers. So all the rains, and we'll talk about this a little later, all of the rain's going to come down the mountains and get funneled into just these river systems. And a lot of times they're going to grow and grow and grow with all that extra water and end up flooding. So that's another reason why rain gauges and understanding rainfall, so precipitation, is very important.
Awesome. The next thing we have to talk about is wind. And there's actually two ways to measure wind. The one way we want to measure wind is how fast is it going, right? This is an anemometer, and this tracks and records wind speed. This one right here wouldn't record because it doesn't have a small computer in it, but a lot of anemometers have a teeny tiny small computer inside of it that records how fast the wind is blowing. So this one is a little bit crazy, but if wind was pushing on the cups, these cups are hollow right here, so the wind gets stuck here and continuously will be pushing the cups all the way around. So as many times as this spins around is how fast the wind is going, right? And then what's the other way to measure wind, Ms. Abby?
Wind direction.
Exactly, right? So it could be going 30 miles an hour, but that's no help if we don't know which way it's going. Is it pushing the water from the ocean towards us? Is it pushing the water from the ocean away from us? It's really important to understand. So that is why we have a wind vane, right? So this does spin around, but it doesn't continuously spin like our anemometer would. See how these guys are different? This one is just going to be pointing in the direction of the wind. So right now there's no wind in here. But if there were, it would be telling us that the wind is pointing that way. And if it were to move this way, the wind direction would be going that way.
All right, so we talk about wind speed, we talk about wind direction. And lastly, we have this one, which is kind of an all-in-one instrument. It's kind of funky looking, but I'll take off the lid so we can look at it inside. And so this one is a combination of many different weather instruments, and you might be able to read these right here, but I'll go through them. The one on the top says barometer. So barometer, it starts with the Greek root meaning baros, or used to measure weight or air pressure. So remember, we talked about the weight of that air on us. So the atmosphere has pressure. And so barometers are a way to measure that air pressure. And so you might be able to see it says little words on here like dry, fair, rain, stormy. And so the air pressure, when we measure it, can tell us a lot about what the weather will be like. Will we have clear skies or will we have cloudy skies? Right below it, we have another temperature gauge. So we have our thermometer. Thermos is the English word for heat. So we measure our temperature in Fahrenheit, so degrees Fahrenheit. Not everywhere around the world uses Fahrenheit. A lot of places will use Celsius, and that's something that we use in science a lot. It's just easier to do equations with Celsius, but we definitely use Fahrenheit in America, in the United States a lot. All right, and then lastly, we have this one down here called the hydrometer. And this one we briefly brought up outside when we were talking about humidity. So hydro, we can think of water when you see hydro. And if we remember outside, Miss Meg mentioned that humidity is understanding how much water is in our air. So this hydrometer is going to help us understand what % of the air has water in it and how much water. And that's a really good way to tell if it's going to be sticky and humid out or if it's going to be really dry and I need to put on some lotion.
That's awesome. Thanks, Miss Abby. So we went over all these different instruments, but I think Miss Abby has a favorite one that she wants to show you how to make. And which one is that?
Well, I really like the anemometer. Because as Ms. Meg was saying, there's ways that you can calculate the wind speed using these. And although this one doesn't have a computer in it, you may notice that this one cup is red while the rest of them are black, right? And the color is going to matter because as it spins, you can count, shut myself in the mask. As it spins, you can count how many times this red cup passes you. And then if it passes you, let's say 5 times in 1 minute, then that's going to give you a reference of how fast your anemometer is spinning. All right, so that's a really cool way, and we're going to test wind speed, and so we're going to do that together today. We're going to make an anemometer, and we are going to share with you a way that you're going to be a meteorologist and test the wind speed right at your own house. All right, so here's a short video of how you can make your own anemometer.
Need 2 straws, a pencil with an eraser on the end, 5 3-ounce paper cups, a push pin, and a hole puncher. Start by using the hole puncher to punch 4 holes opposite each other just below the rim of one of the cups. Then, push the 2 straws through these holes. Use the hole puncher to punch 2 adjacent holes in each remaining cup. Thread each of these cups onto the ends of the straws through the 2 holes. Make sure the cups all face the same direction around a circle, meaning they all face clockwise or all counterclockwise. If one of the cups is backwards, then your anemometer will not work. Next, use the tip of a sharpened pencil to poke a hole in the bottom of the center cup. Press the pencil through the hole eraser first and wiggle it slightly to widen the hole so the pencil can rotate easily. Lightly press a pushpin through the two straws and into the eraser. Do not push it in too far or this will create too much friction and your anemometer will not rotate. Stand your anemometer up on end and try giving it a spin. If it doesn't spin, try loosening the pushpin to reduce the amount of friction. Now, hold the anemometer up in front of the fan or take it outside on a windy day. Observe how fast it spins when the wind speed changes. To see written instructions for a science project and classroom lesson plan you can do using the anemometer, visit the links at the end of this video. To see thousands of other science and engineering projects, visit us online at www.sciencebuddies.org.
So what are we going to do next, Miss Meg?
We are about to do an experiment for you that has to do with convection.
So what is convection?
Convection is the movement of heat. So whether there's hot air or there's hot water or there's cold air and cold water, there's going to be some movement between the different molecules. So we're going to make a prediction right now. In front of me, I have cold water and I have hot water. What do you think is going to happen when we mix them together? I'm going to put the cold water right on top of the hot water. What do you think is going to happen? For more information for you, we have a diagram or a model that represents what these look like. So this represents the particles of the cold water. They're densely packed together. They're cold. They want to be close to each other. They don't have a lot of movement, a lot of room to move around. This represents the warm water. The water is free flowing. It has a lot of room for the molecules to move around because it's nice and warm. Kind of like how our muscles feel when it's cold outside and we're cold and we're shivering, or it's warm outside and we're flexible and able to move around.
And that's a really good point, Miss Meg, because you can see it sometimes when it's really hot outside and if you've been running around or playing a sport, sometimes your fingers will expand and sometimes you can't get your rings off or things will expand. You can feel yourself swelling up a little bit. We see that with jam doors in the summertime. Things expand when they're hot. They move around, they move upwards.
Awesome. And that same thing goes for air. So that is how we're bringing this back to weather, right? So when we have warm air and cold air, different things happen. And we're going to show you exactly what's going to happen when warm air is mixed with cold air.
So quick, make a prediction what you think is going to happen when we're going to start with putting our warm water on top of our cold water. So let's start with that. Go ahead and think to yourself what might happen. Line them up. Okay, go. So we don't really see a whole lot of changes here, right?
The red warm water made the blue a little bit darker, but at the top, I think I only see the red at the top.
Right. All right, now we're going to switch over to the next one. All right, so real quick, go ahead and make your predictions for what's going to happen when we put the hot water on the bottom. So now we're going to put the cold on top. All right, Miss Meg, are we ready?
We're ready.
Would you like to do the honors?
Mm-hmm.
All right. So we'll give it some time to react here a little bit. But as you can see on this time, they're all becoming one of the same color. So why do we think that happened, right? So the hot red water is air. It would happen too if it was air. The hot red moved upward. The heat pushed it upward to mix with the cold water. So now is one mixed homogeneous mixture with hot and cold. So that's a really good way to visualize the movement of heat.
Next, we are going to briefly talk about cycles. So just like convection, there are a lot of patterns we see in weather. That's because all of our Earth's resources need to be recycled. On the screen, you can see a few examples of different cycles that we see in our climate and on the Earth. We will only be talking about the water cycle, as the movement of water really has a big influence on our weather.
All right, so if you have not visited our museum before, here is a short preview of what we have. So this is our water table. Our water table is a really good way to talk about and learn about the water cycle. So the water cycle has a lot of different parts to it. And actually we have a little diagram over here that will show you. You may have heard some of these words before, but there are words like evaporation, transpiration, condensation, precipitation. So those are the main components to the water cycle. We can talk about evaporation when water is taken up and into clouds. So that's how clouds form. Really humid air rises and all of the water droplets collect together and form little bombs. And when it gets so heavy, that cloud will rain down. So we have evaporation and then precipitation. And let's actually take a look at where that water goes. All right, so first, precipitation, right? It's coming down from the clouds, and we see the waters come down the mountain and make their way into river streams. Those rivers come all the way down to cities to supply us with our source of fresh water. There's only a limited source of water in the world. It's finite, which means we will run out of water someday if we don't take care of our environment. This is because the fresh water is actually just recycled. So we never really create or destroy water. Water is just recycled, and that's why it's called the water cycle.
Evaporation isn't the only way that clouds are made. Trees and plants also give off water through transpiration. We can see that a little bit on this diagram. But really, when the clouds start to build up a lot, it's important to understand what that means for the water cycle. It helps us predict when bad weather's coming. Let's see what it looks like when we make a rain cloud in a jar. To do this experiment, we don't need much. We just need some shaving cream, a mason jar or a glass jar filled with water almost all the way. I am going to use a plastic pipette, and then you need some blue food coloring and a little bit of water. So that, we're going to take the shaving cream first, and we're going to shake it all up. And we start to push it out and form a cloud right on top of our water. So that's going to be our cloud. Next, I'm going to take the pipette and I'm going to suck up a bunch of my blue water, and this blue water is going to be the rain. I'm going to start to fill up my cloud with water, just like it would during evaporation and transpiration when water is taken up into the atmosphere in forming clouds. As this happens, the clouds start to fill up, and get really heavy with a lot of water vapor. Eventually, they'll get so heavy that they open up and let down rain.
we end and say goodbye to you guys, we have one last topic that we want to talk about, and that's extreme weather, which is really important today because we see a lot more of it happening all the time, all around the world.
Right. So we talked a lot about cycles and patterns to weather. Extreme weather is actually just one of those. So we're able to predict extreme weather, right? You might hear once in a while a tornado warning, depending on where you live, or a hurricane warning if you're by the coast. So there's all types of extreme weather, and maybe you can think of some that we see around Western North Carolina, like a thunderstorm.
What makes extreme weather? So we know what makes weather now. So what makes extreme weather? It's all of the things we talked about today, but intensely. So for example, really high wind speeds. Wind speeds that could do a lot of damage to you and me and our houses and our buildings. It also includes a lot of precipitation all at once. When it rains a lot in a short amount of time, that can cause intense flooding or storm surges.
Right. So we think about when hot air, or what we saw in the convection experiment, hot water, when that mixes with cold air, cold water, there is this sort of shift. So the hot air is going to rise and something's got to replace that air. So the cold air will come in, and the mixing of those two temperatures are going to help provide a lot of that, what we need for that extreme weather to happen. So let's use hurricanes as an example.
As tropical seawater is heated by the sun, this warming air rises into the atmosphere, forming rain clouds, while down below the warm air is replaced with cooler air, which is warmed and rises. It's like a cycle, and the cycle repeats over again, as long as there is a supply of warm seawater. As the clouds cool, rains fall, and winds develop. The Earth, as it rotates, causes the storm to spin.
I'm Dr. Jeff Binnicker, and today we're going to explore extreme weather solutions. Extreme weather is any weather that falls outside the realm of normal pattern, like a tornado
Or a hurricane.
What? That stuff can get pretty extreme, let me tell you. Extreme weather, not bird poop, causes a lot of damage. Why don't we come up with ways to lessen the damage? That's a great question. We can't actually stop extreme weather from happening, but we can reduce its impact.
Can we reduce the impact of extreme weather by trying to predict it?
Absolutely. By looking at past patterns of extreme weather, we know what regions on Earth are prone to different kinds of risks. For example, we know when it's hurricane season in the Atlantic Ocean by looking at patterns. Based on centuries worth of data, we know that the period between June 1st and November 30th of each year is when hurricanes are expected to develop across the Atlantic Ocean.
So each year, the people in the area near the coast can get prepared in case a hurricane happens?
That's right. How else can we reduce the impact of extreme weather?
What about coming up with new inventions and building methods to help lessen the damage?
Yes, we call those engineering solutions, and they help us reduce the effect of extreme weather.
We're sorry.